Hello there. Today we are going to be solving a problem from the CODESPARK competition held by the Codeyantra committee of SLRTCE. This problem is named as Zigzag Conversion and it falls into the medium category of problems from LeetCode. Admittedly, this is one of the most challenging problems from the competition and not an easy one to get a solution of. Yet we'll go over the problem statement, see a couple of examples, and try to come up with an algorithm with a decent time and space complexity. So let's begin with it. So for this zigzag conversion problem, you'll be provided with an input string s. This input string consists of a certain number of characters. Suppose you're given an input string such as there will be no line breaks within the string. I had to include a line break here because I lacked some space, but the string will contain characters only. So given a string s, such as PayPal is hiring, and given a number of rows n, let the number of rows n be equal to 3 here. N could be anything ranging from 1 to any number, basically any integer number, and your job is to grab the string, grab the number of rows, and arrange the characters in the string in a zigzag pattern using the given number of rows. So for a given number of rows, 3, we'll start converting the string into a zigzag pattern. You might not be able to identify a zigzag pattern here, but let me do that for you using a different color, of course, and increasing the width of the brush. Now the zigzag pattern should be more visible. So we basically begin with PAV, PAY and move downwards. Once we have covered 3 rows, 1, 2, 3, we need to follow an oblique path and move upwards, right? So once we have moved downwards, we need to move upwards. And since this is a 3-row arrangement for the given string, we'll only have a single character in the middle while moving up. And that single character is P, as you can notice. We move down once again by a number of 3 and move up once again with S being the intermediate character. Let's consider n equals 4 so that we cover some even test cases as well. Now for n equals 4 number of rows, we'll try to arrange the same string PayPal is hiring into a zigzag pattern as follows. Now I'll try to help you visualize the zigzag pattern here as well. As you can see, a zigzag path is formed here as well. However, once you have formed a zigzag arrangement with a given string s, you need to return a certain result, and this result is going to be to read the zigzag arrangement row by row, column by column in this fashion and return that as the string. So if n equals 4 and s equals the given string PayPal is hiring, we need to return this as the final result. PIN. This covers the first row. Now we need to move into the second row. PINALSIG. This covers the second row and all columns within the second row. Now we need to move into the third row and so on, and concatenate the characters from each row and return that as the result. That might sound intimidating, but once you get the hang of a couple of patterns going on within this pattern, it will be all right. So let us start by analyzing the structural arrangement of this given string. if we need to get the next character within a given row, we need to traverse a certain distance within the string s, right? For example, if we want to move from index 0 in the input string, now to get the index of the next letter in the row, which is I in this case, we need to move from index 0 to this index right here. Let's calculate that. I is at index 6. Similarly, n is at an index of 12. So as you can see, for the elements in the first row, they are at a space of 6 unit distance from each other. Now if we move on to the second row, you'll see that the pattern changes, and that might be annoying, right? Because between two letters within the same column, there's an intermediate character, and we need to account for that. So but without considering the given intermediate character L and I, let's calculate the distance between the columns. 7. Now 7 minus 1 is still 6. So the distance of A from S is 6. Similarly, the distance of S from G is still a 6. Now what is the distance of the element L from A, which is the intermediate element? Let us calculate that. 0, 1, 2, 3, 4. Right? It is at a distance of 4. 1, 2, 3, 4, 5. Right? So 5 minus 1 is 4. So it is at a distance 4. Similarly, I is at a distance of 4 from S. Let me write down the distances in each row. The distance between P and I is 6, and the distance between I and N is 6. The distance between A and L is 4, and the distance between L and S is 2. How did I know that? I just subtracted, right? Moving from L to S requires us 2 traversals, 0, 1, 2. So the distance between L and S is 2. Now the distance between S and I is 4, and the distance between I and G is 2 as well, right? Because when we move like this, when we move like that, we count 0, 1, 2. So the distance between I and G is 2 as well. For the third row, let us count the distance between Y and the intermediate element A. 0, 1, 2. It is still 2. Let us count the distance between A, which is the intermediate element between the two columns, and H. It's going to be 0, 1, 2, 3, 4. Similarly, we can say that the distance between H and R is 2 as well. Further, no characters exist, so we might not need to calculate that distance. Finally, for the last row, we'll calculate the distance as well. 0, 1, 2, 3, 4, 5, 6. Now, if we write out these distances, we might get a pattern that you might have been able to figure out by now. Initially, the distance was 6 between two elements, and there was no intermediate element. Next, we had an intermediate element, and the distance between the first element and the intermediate element was 4, and the distance between the intermediate element and the next element was 2. Finally, the distance between the first element and the intermediate element in the third row was 2, and the distance between the intermediate element and the next element was 4. And this pattern repeated over any number of repeated over the columns, right? And finally, we had a distance of 6 and no intermediate element. This might be a bit easier to process and determine a pattern from if I write something like this: 6 0 4 2 2 4 and 0 6 once again. Now we begin from suppose 6 is an element n. No, not n. Let that be d, representing distance. If 6 is a distance d, let it be d1 and let it be d2. So the next elements in the list are d1 minus 2 and d2 plus 2, right? So 6 was d1 and 0 was d2. For the next row, we put d1 equals to d1 minus 2 and d2 equals d2 minus 2, d2 plus 2. And we did the same until we reach the final column where d1 becomes 0 and d2 becomes the initial d1. But how do we know what d is for a given number of rows, right? It must be unique for a given number of rows. Well, let's draw out the PayPal is hiring string for n equals 3. Suppose we need to find the distance between P and A. In this case, it is 0, 1, 2, 3, 4, right? So for n equals 3, D is equal to 4. For n equals 4, D is equal to 6. As you might have noticed, there is a pattern, and this pattern is given by a mathematical formula that, if your mathematical reasoning is good enough, you might be able to find. D is equal to n minus 1 multiplied by 2. And you can check this for any number of rows, n equals 4, 5, 6, 7, 8, and so on. And this mathematical formula will always hold true. And using this property, calculating d initially, which is n minus 1 star 2, if we write it in mathematical terms, in programmatic terms, and decrement and having two d's, d1 equals d and d2 equals 0, and moving from d1 equals d to 0 and moving from d2 equals d, we will be easily able to find the resultant string. How would we be able to do so? Let me demonstrate a bit. Because we also need to account for places when the character does not exist, right? Let me whip up that example real quick where we have n equals 4 rows. Now when we traverse through the string, we need to get the access to I element when we are on element 0, right? So we move from, as we know, for n equals 4, distance is equal to 6 initially. d1 is equal to 6. So we go 0, 1, 2, 3, 4, 5, 6, and we get I, right? But what about the 0? In this algorithm, whenever we encounter a distance 0, it indicates that there is no intermediate element. There is no intermediate element. If there is no intermediate element, we do not need to account for that distance. And similarly, once we are on I, we can calculate the distance at which n is located by adding 6 d1 to I. What about the second row where we have an intermediate element? If we have an intermediate element, as in the second row, we need to move back and forth between d1 and d2. For example, initially when we are on element A, we will consider distance d1 and we'll add I, the current counter index I, to d1, and we'll get L. Next, on the next segment, we'll do I plus d2 to get element S. And once we have got an element S, to get the element I, we'll do I plus d1 again, and so on until we get a null character. Right? So we'll alternate between d1 and d2 to get the distances, to get these distances and access the element. We'll do the same for the third row and for the final row, keeping in mind that whenever we encounter a 0, we'll just skip that loop and increment the counter. We're going to try to code this solution up in the next session. First of all, I'm going to declare a function called Zigzag Conversion, which is a function expression in JavaScript, taking in s, the string, and num_rows as the arguments. I'll close it off with a semicolon, come back. We're going to be eliminating a few edge cases right away so that we save some time. And if num_rows is equal to 1, or s.length is equal to 1, or s.length is equal to 2, we are gonna be returning the same string back, because if these conditions apply, we do not need to process the string any further, and we can just return the string back. The string is too small, or the number of rows is just too small for any possible rearrangement of the string to take place. Further, if those conditions are not satisfied, we'll move on to with our algorithm. We'll require a dist variable, actually this is an array, which will hold the distance between the nth column and the intermediate element, and the intermediate element and the n+1 column. The first distance is going to be num_rows minus 1 star 2, and the second distance is going to be 0, right, as we discussed in our solution video. We are also going to be having a top pointer, which is going to point to one of these distances, and it's going to alternate during each cycle. Initially we'll set it to 0. Also we'll have a resultant string, which is going to be empty initially. However, after all the processing is done, it'll contain the result, which we are going to return at the end. Now let's start with a for loop, which goes from let I equals 0, I less than num_rows, I plus plus. Basically, we are grabbing the first element of each row, and we are gonna process the resultant string segment until we encounter an undefined element. We say let count equals I. This will help us find the distances between the intermediate element and the rows on the either side, columns on the either sides, while s count is not equal to undefined. So while the s count exists, what we are gonna do is if dist top, if dist top is not equal to 0. So just in case that there is an intermediate element which exists between the two rows, we are gonna concatenate that to the resultant string. Res plus equals s count. Now once we have checked that, we are gonna be alternating our top. So top equals top plus 1 modulus dist dot length. This is a mathematically clever way of alternating between elements. This was taught to us back in our data structures classes, so a cool little trick to remember. Now we'll also increment count by dist top, and this will help us grab the elements which are valid to be placed in the resultant string for a given row until we encounter an undefined element which signifies the end of the resultant string segment. Now below that we'll decrease dist 0 by 2, and we'll increase dist 1 by 1 by 2, and we'll also reposition top to 1. After this processing of the resultant string, we are just gonna be returning res, and that should be the solution for the zigzag conversion problem. It might have been a bit tricky to come up with the actual solution, but once you know it, the coding it up is kind of trivial. We'll save this file in NeoVim using the escape command first to enter the normal mode, escape the insert mode, press :W to save the file. As it shows, 466 bytes were returned with the file. Now we'll escape the command line editor with QA dash exclamatory mark. And there you have it. If you're interested in learning more about the Linux environment on Termux Android, you can reach us out or ask us to create a video on it. So until then, see you next time and keep coding. Thank you.